All right, welcome back everybody. Today in lesson 3-5, we're talking about parallel lines and triangles. Now you might be thinking, what's the relationship between all this parallel lines stuff we've been doing and triangles? Well, we'll show you what that is in a few minutes. Okay, objective today, once we kind of show you that relationship, is going to be just to find the measures of angles in triangles. Okay, here we go. All right, so let's experiment with triangles a little bit. So what I have on the screen is a dynamic triangle, okay, something where I can adjust the angles and the side lengths to make it a smaller triangle, like so, okay, or a larger triangle, like so. And as I'm doing that, notice on the left side of the screen, the computer is automatically measuring each of those angles for me and giving me a visual representation. So essentially what I have here is a way to come up with all possible triangles as I go through here. Now the other thing that's happening is the computer is also taking the values of those three angles and adding them together. And right now it's telling me that sum is 180 degrees. And notice as I move things around, that sum doesn't change. Okay, at first we might think, well, maybe it's broken, maybe it's not calculating, but notice that as those three angles kind of move around in this semicircle here, we can see they're always adding to make a straight line, so they're always adding to 180 degrees. Okay, I can kind of further that by clicking this rotated angle here, and yet we can see if I take all three of these angles here and put them together, I get a straight line. Okay, so a conjecture I can make based on inductive reasoning, based on the pattern I'm seeing here, is that it looks like a triangle's angles are always going to add to 180 degrees. Okay, I'm going to say that conjecture is the triangle angle sum theorem, which states that the sum of the measures of the angles of a triangle are 180. Okay, so if I take three angles, A plus B plus C, and add them together, I get 180. No matter what the triangle is. Now we said that was a theorem, and remember a theorem is a conjecture that we can prove is true. So real quick, let's go through the proof of that. Now you don't have to copy this down or write it down or memorize it. We'll just show you. And the big reason I want to do this is I want to show you how our triangles relate to the parallel line stuff we've been doing the last few lessons. Okay, so let's prove that. So I have my triangle ABC. And the thing that I need to add to this proof is a line through B parallel to the bottom of my triangle. Okay, what that's going to give me are parallel lines with the other two sides of my triangle as transversals. And what I know with these parallel lines and transversals, angle A and angle 1 are alternate interior angles, which, since the lines are parallel, will be congruent. So I know that A and angle 1 have the same measure. And the same thing if we look at BC as a transversal, I have parallel lines with the transversal. Again, we have alternate interior angles, which we know will be congruent to each other. All right, so as far as a simple version of this proof goes, visually I can see that angle 1 and angle 2 and angle 3 add to 180. Since they form a straight line when they're put together, they make a straight angle. Right, now what I can do is substitute angle A for angle 1. And instead of angle 2, we can say just this angle B here, because they're talking about the same angle. And instead of angle 3, we can say angle C. All right, so since angle 1 plus angle 2 plus angle 3 equals 180, and angle 1 is the same as angle 2, or sorry, same as angle A, angle 2 is the same as angle B, and angle 3 is the same as angle C, we know that A plus B plus C also have to equal to 180. Okay, so that's where our parallel line properties come in, okay, for the proof of the triangle angle sum theorem. All right, so let's go ahead and show you how we can use the triangle angle sum theorem. Now, we're going to give you a couple of examples of ways these can work out together here. Okay, the homework's going to have a whole bunch of other different situations. So the goal is we'll provide you with enough examples that you can apply them to some different ones. Okay, so obviously some problem solving involved as we're going through these. Problem 1, part A says, what are the values of x, y, and z in the diagram? And I have a few different triangles here. We have 2 smaller ones, then a larger one if I put them together. And we know some of the angles. We want to solve for some of the angles. And we'll use the triangle angle sum theorem to do that. Okay, there's different ways this problem can work out. Probably most straightforward would be to find just x, y, and z in order. So let's do it that way. So for x, what I can do is I can use this smaller triangle on the left here. Now I know 2 out of the 3 angles, and I know any triangle is going to add to 180 degrees. So anytime I know 2 of the 3 angles, I can subtract from 180 to get the third one. So for x, we can say we have 180 minus 59 minus 43, which will give us a 78 degrees. Once I have that x, I can find the y. Since x and y make a linear pair, to get y, I can just subtract x from 180. So y will be 180 minus the 78 we just found, which will be 102 degrees. So I know y is equal to 102. And then once I have the y, it's pretty easy to find the z. We'll look at the triangle on the right. Again, I know its 3 angles have to add to 180. That's my triangle angle sum theorem. So what we can do is 180 minus the 102 minus the 49, okay, to get the z. Which will leave us with 29 degrees. All right, so there's our triangle angle sum theorem in action. Again, anytime we know 2 angles of a triangle, we can find the third one by subtracting the 2 we know from 180. All right, in part B, we're going to show you how we can solve an algebra type problem using our triangle angle sum theorem. So B says, what's the value of x in the diagram? So we have a triangle, we have expressions for all 3 angles, and I'm going to need to set up an equation to solve for x. Now what I know is that for any triangle, again, all 3 angles should add to 180. So what I can do for this one is add all 3 angles together. We can say 4x plus 7, all right, plus 8x minus 1, plus the third angle, which we don't have an expression for it here, but this box tells me it's 90, and set that all equal to 180. Okay, again, we know all 3 angles of a triangle always add to 180, so I can take those 3 pieces, add them together, and set them equal to 180. That gives us an equation to solve. Now it looks kind of ugly right now, but once we combine like terms, it won't be so bad. I'm going to combine my x's on the left. 4x plus 8x will give me a 12x. And the numbers, we have a 7 minus 1 would be 6, plus 90 would be 96. And then once like terms are combined, we can solve for the x. I'm going to do that by subtracting 96 from both sides, which will give me a 12x is equal to 84. And then we'll divide both sides by 12 to end up with x equals 7. All right, so there's an example of using our triangle angle sum theorem to solve a problem involving some algebra. Again, the key for that is we know that all 3 angles of a triangle add to 180, so I can add all those expressions up and set them equal to 180. Okay, we're going to talk about one more theorem involving triangles, and this one's going to deal with exterior angles on triangles. Now, I didn't define it for you here, but it's pretty easy to visualize what an exterior angle is. An exterior angle is just an angle formed by the extension of one side of a polygon and its adjacent side. So angle 1 is an example of an exterior angle here. And we've got a few different examples of triangles with exterior angles. And the theorem we're going to give you about exterior angles of triangles is that the measure of each exterior angle of a triangle equals the sum of its two opposite interior angles. So for example, angle 1 here, which is an exterior angle of the triangle, is going to be equal to the sum of angle 2 plus angle 3, which are interior angles on the opposite sides of the triangle. Let's go ahead and apply that theorem to a problem. So problem 2, part A, says what's the measure of angle 1? Now angle 1 is an exterior angle. And we also know the two interior angles on the opposite side of the triangle, not adjacent to angle 1, but across from it. So that theorem just told me that angle 1 will just be equal to the sum of the two opposite angles. So in other words, 80 plus 18, which will give me a 98 degrees. All right, so pretty simple question when we have that theorem. Now, we actually don't need that theorem for this question. If you forgot it, you could still do it. And basically the way I'd do that is I'd find this other angle, this other interior angle on the triangle by going 180 minus 80 minus 18, which would give us an 82 degrees. And then once I have that, I can use the linear pair right here to go 180 minus 82, I'd get the same 98. Okay, so the theorem's a nice shortcut, but it's not actually necessary. Let's take a look at one more way we can apply that triangle exterior angle theorem. In part B, it asks, what's the measure of angle 2? And once again, we have a problem where we're dealing with both exterior and interior angles. Notice this time, though, they gave us the exterior angle, and I need to solve for one of the opposite interior angles. Okay, we can use the same formula. Exterior angle equals the sum of the two interior angles. So in this case, the exterior angle is 124 degrees. And that's going to be equal to the two interior angles added together. So we'll say equals angle 2 plus 59. So for this one, to get the angle 2 by itself, we'll subtract 59 from both sides of the equation. Subtract 59 from 124 degrees. Which gives us angle 2 equal to 65 degrees. All right, so that's how we can use our triangle exterior angle theorem to find interior angles as well. And then once again, it's actually not necessary to apply that theorem. We could do it without it by using this linear pair here. If I subtract 124 from 180, that's going to give me a 56 degrees. And if I took 180 minus 59 minus 56, we'd get the same 65 here. Okay, just by applying the normal triangle angle sum theorem. All right, there you go. That's how our triangle angle sum theorem works. We gave you a few different examples of it. The homework's going to show you a bunch more. So do your best to apply what you learned here to the problems in the homework. And it's really a great section for problem solving, making you think critically, okay, making you try some different stuff. So give it a shot, thinking involved, and like always, let us know if you're getting stuck and need some help.